Right, this is a complex numbers problem solving the roots of an equation. It's a quartic equation. So um, here we go. F of z equals this thing here, z to the power of 4 plus a z cubed plus 6z squared plus bz plus 65. Z is a complex variable, and a and b are real constants. Okay, and we're told that 3 plus 2i is a root of this equation, and show the roots of that equation, f of z equals 0 on an argand diagram. Okay, so the key point here is that if 3 plus 2i is a root, then so is 3 minus 2i. So they always, the complex roots always occur in conjugate pairs. So 3 plus 2i and 3 minus 2i are conjugates, and if we look at them on the Argand diagram here, then we can see that there they are. They're sort of mirror images of each other across the real number line. Okay, so therefore we're saying that the function is divisible by this z minus one root into z minus the other root, which actually, once we multiply that out, we see that that's equal to that. So yeah. So what do we need to do now in order to find this? We're basically, well, the most straightforward way is to say, look, we know h of z is going to look something like this, where theta and phi are real variable, real numbers. And when we multiply these two together, we're going to get this horrible expression. It's a bit messy, isn't it? We've got this great long thing here. But once we've done that, then we can compare. We can compare coefficients. We'll get rid of that. We can compare coefficients, and so if we're looking at this, then 13 13 phi is the constant, so that's a nice straightforward one to look at, and that's going to be equal to 65. So phi is equal to 5. 13 phi equals 65, phi equals 5. Right, so we can actually rewrite that. We've now just got one unknown in it, that's theta. And I think we can compare, what are we comparing? The coefficient of z squared. Yeah. So we've got that occurs there twice. No, sorry, not there. We've got that, and that. So it's 18 minus 6 theta in all together. And that's equal to the 6 up there. All right, so that's giving us theta equals 2. And therefore, we've got the kind of all the details of this quadratic here is going to give us that. And then when we solve that, all right, kind of skipped a step here, but we can sort of easily solve that using the calculated quadratic formula or whatever we need to do, and that's going to give us these other roots, which, as we can see on the Argand diagram, are again mirror images of each other across the real number line. So it's kind of fairly straightforward, really, I think, but just a little bit messy when you end up with a great big expression like this. It's easy to make a mistake, so I have to take a bit of care. But hopefully that has been helpful. So thanks for watching.